So now if I take COR minus REP, I get the differences in the two correlation matrices. Now, a more straightforward approach. You can just create this right off the bat to get the same matrix. You can just do factor residuals, and we want our correlation matrix with our PCA 1? Yeah. And you'll notice that you get exactly the same thing. So this is just the residual, the difference between the observed and what we currently have. And this is just doing the brunt work to show you that they're just a difference between two matrices. Guys, these differences should be small. So a good model, correct number of components. The differences in the correlation should be small. I think that's for obvious reasons. But another way for doing this is not only to examine the differences and just go through each and every item in the difference of the correlation matrix and the reproduced correlation matrix. Another way is to examine the fit based upon off diagonals. Remember way back, right here, this value right here that I told you would play a role. It turns out as long as that is greater than 0.90, then we have made a good choice in terms of the number of components. So as long as that's above 0.90, ideally we like it above 0.95, but the threshold also was 0.90. So guys, I am very happy with 2 components. Everything that I see, the scree plot, the factor loadings, the drop off in the percentage of variance that's explained by the 3rd component, 4th component, 5th component, the 6th component. Again, the inflection point on the scree plot, this value right here being above 0.9, these values being very small in the difference of the correlation matrix and the reproduced matrix. I am a happy camper. I think that 2 factors is a perfect choice. Aren't you happy? Okay. So guys, let's review a little bit just for the sake of moving on. I told you this is going to be a long video. I'll probably have to divide it into 2 parts to get it uploaded. Because we're getting ready to get to some cool stuff from here on out. So, first question. How many components should we retain? I would always retain the eigenvalues, the components that have eigenvalues greater than 1. And examine a scree plot. Now, where things get wacky is when these two things don't agree. And if that ever happens, that's when you just get into the literature and start seeing what you're supposed to do, which one you're supposed to agree on. One rule of thumb, I will tell you, is when the number of variables is less than 30, depend on the eigenvalues greater than one criterion. Okay? And the next thing, examine the model fit that we get from our output is greater than 0.90, ideally above 0.95. All right, boys and girls, I am ready to make some good stuff happen now. All right, so we're, or at least I am content with two factors, so let's start the process of rotation. Now, what I want to do is there's two types of rotation. There's orthogonal and there's oblique. And I am going to illustrate both of these for you. And this might be a good place where I actually split the videos, because I think this one's going to run into quite a bit. I can already tell my battery's about running down, so I may have to get that taken care of. So, but anyway, I want to do some rotation. So first thing I have to do is I have to install a package called GPA rotation. Oh, install packages. All right, so done. Let's access the library. Okay, now I'm going to run my second model, so I'm going to call this PCA 2. And I'm going to use principal just like before, still data, ecstatic with my two factors. Because now we're going to bring in the most commonly implemented orthogonal rotation process called Varimax. All right. Hit enter, type PCA2, and let's see what we actually get here. It looks like to me that the commonalities did not change, but clearly the eigenvalues did change. So now our factor loadings are much more interesting. So if I look down on component number 1, what I want to look at here is I want to look at the components or the eigenvalues greater than 3. Greater than 0.3. So guys, don't lose me now, okay? This is one of those drum roll please. You know, this is an important point here. We're trying to find out this underlying structure. We're trying to find out which variables load on component 1 and which load on component 2. Actually, since we've done the Varimax rotation, we're actually going to call these, begin to think of these as factors instead of components. So it looks like to me that calculus, trig, and algebra are all greater than 0.3. So it looks like to me that calculus, trig, and algebra are loading on component 1. And it looks like to me that problem solving, logic, and statistics are all loading on component 2. Now, something that might help there is such a emphasis put on this eigenvalue being greater than 0.3, dictating what loads on what component. So there is a print psych option, and we can run it for PCA2, where the cut is equal to 0.3, and I want to sort equal to be true. And this is just going to put it from high to low. So what happens then is it gives me just a better visual on what's actually loading. So you can see that the factors that load highest on component 1 are trig, calculus, and algebra, and the ones that load on factor 2 are problem solving, logic, and statistics, and it sorts it from highest to lowest. So our commonalities and our uniqueness still haven't changed. Okay. And notice that we're still right at 3/4 or 75% of the variance is still explained. Okay. Well, guys, I'm a happy man. If I were really publishing this, I would be extremely happy. And let me show you why, because it's all starting to kind of make sense. And it's crazy how many times this does make sense, okay? So rotation has clarified our model. Somewhat, okay? So factor 1 loaded calculus, trig, and algebra, while factor 2 loaded stats, logic, and problem solving. These are all observed variables. But I think you can see the construction of some latent variables emerging from the commonalities within each factor. So the latent variables, at least for me, for factor number 1, it's amazing how this falls out, are things that require symbolic manipulation. The latent variable underlying factor 2, statistics, logic, and problem solving, now, I don't really know what I would call that. Maybe more of a liberal arts math. I don't know. Probably a better term for that. That's one of the most frustrating things about once you run factor analysis and you get these things that load on these particular factors. What do you call them? And sometimes that's really kind of crazy. Now, let me tell you something that may happen is let's say, for example, you, and this happened to me one time, I had question 1, question 2, I had 25 questions from a developmental math test. And these things emerged on factors. I remember there were 3 factors that emerged. And, these went different ways, right? Well, all the questions that emerged on factor 1 were out of chapter 1, probably chapter 2, whatever it may be. All of these were out of chapter 2, and all of these were out of chapter 3. Not necessarily factor 3 was out of chapter 3, but factor 3, these questions all came from the same chapter, except for a couple of questions. So what I ended up doing to tighten up the model is the questions that didn't load naturally on the particular factor that corresponds to the particular chapter, is I came in and just deleted those, and it just really strengthened up the model. Okay, so that could be something that you'll run into. So, gang, let's get back to R and see what's happening here. So again, I'm feeling really, really, really good. Okay. Now, what do these numbers mean? under RC1 right up here, these loadings. What this tells us, well, I'll tell you what, if this were a negative number, and sometimes these numbers are, it just tells us that a high score on the factor indicates a low score on the subject, because we're ultimately going to create what are called factor scores. And so again, higher scores on the factor indicate a lower score. But these are all positive, so this tells me that a higher score on this first factor indicates a higher score on the trig factor and calculus and algebra, and the same thing for factor number 2. Okay? Now, guys doing a lot of jumping around here, but it's just one of those things. Orthogonal rotation. Which we used with Verimax, assumes that RC1 are uncorrelated. So it assumes that symbolic manipulation and liberal arts are independent. They're not correlated. Now, is this true? Probably not. And when you can justify that your components probably are correlated, then you get into a situation where you may consider a different type of rotation. Now, guys, orthogonal rotation just says that we turn things, think about it simplistically, 90 degrees. Oblique allows us to make more sophisticated types of rotations. So what we can do to run this is, well, I'll tell you what, let's just go run it. So what I want to do now is I want to create a new model. But I want to run an oblique rotation.